Hello, ladies and gentlemen. Welcome back. We are on lesson 3 of unit 4. In this lesson, we're going to talk about residuals, outliers, and influential point or points. Now, what in the world is a residual? Well, the residual, ladies and gentlemen, is the vertical distance from the least squares regression line to the data point. The difference between an observed value of the response variable and the value predicted by the regression line. Okay, so let's get a little visual of this. Imagine, ladies and gentlemen, that I have a scatter plot. Okay, I'm just going to roughly sketch one here, like that. And I've got some dots in that scatter plot, like this. All right, and then I've got that least squares regression line. Remember, that's also known as the line of best fit. So let's say that the line of best fit is right there. Well, the residual, ladies and gentlemen, is the vertical distance from the line to the dot. So the vertical distance from the line to each dot. Now, okay, let me make these dots a little bit bigger. So the green line is the vertical distance. Now, obviously, if the dot is above the line, that vertical distance, that residual, is going to be positive. Okay, if the dot's below the line, that vertical distance is going to be negative. And if you think about it, positive and negatives, they cancel each other out. Hence, that line is going through the dots right where it's supposed to be. All right. Now, there's a mathematical formula that we're going to use in the second example to find the residuals. We're going to take the observed, which is the dot that you see, okay, the data point in your graph, and then the predicted value, which is where the line is. That's your predicted. Remember, that line is used to predict what is going to, or what they think is going to be the value at that spot. All right, so this problem is going to be, in fact, all the problems we look at today, we've done once before. So this first problem is we're going to look at that pizza problem again, all right? So I'm going to take a moment and I'm going to go ahead and graph my data onto this graph. All right, so you may want to pause and do the same thing. I'll be back in a second. Gentlemen, I am back. So what I have done is I have taken the pizza data and I graphed it on my graph just like this. And if you remember, this one is perfectly linear. Okay, one topping is going to cost $9.50. Two toppings is going to cost $11, and so on. And this one turns out to be perfectly linear. All right, so now the question is, well, if it's perfectly linear, then that line of best fit, that line is going to go right through the dots, just like that. So what are the residuals of each dot? Well, the dots are right on the line, so that means the residual for every single data point in this case is 0. And I already gave the reason. Why is that? Okay, because the dots are all on the line. All right, so pretty straightforward with that one. All right, let's take a look at the next one. So this one is dealing with the hot cereal sales again, the temperature outside and the hot cereal sales. All right, so what I'm going to do is I'm going to take a moment. You will want to pause. I'll be back with you in a few seconds. I'm going to go ahead and get the graph done and then continue recording. All right, so pause and make your graph. Just a reminder that I'm using my calculator to help make my sketch. Okay, remember to type your numbers in the list 1 and list 2. Make sure that your scatter plot is on. Okay, remember second and then the y equals button. And then pick number 1, make sure it's on and it's the scatter plot. And then you have to quit. And then you can hit zoom 9 to see the scatter plot. All right, I'm going to continue doing this. Be back with you in a second. All right, ladies and gentlemen, the power of technology. So what I've done is I've taken my graph from my calculator and made my sketch, right? Made my sketch. All right, so temperature outside, remember, is the explanatory variable, and the boxes of hot cereal sold is the response. Okay, and then we're supposed to find the least squares regression line. Okay, let's go through that process again. So to find the least squares regression line, remember, we're going to go, let me move this, we're going to go stat, calculate, number 4. All right, and then we have to hit that enter like 5 times, and voila, there are my numbers for my least squares regression line. Okay, I'm going to take a moment and get those written on my slide. All right, so what I did was I took and wrote my equation. Now remember the y hat, that, ladies and gentlemen, is your predicted value. Sometimes it's just not, we can't type it with the hat in. For example, on Google, or not Google, on Schoology, when we're taking the test, that hat probably won't be there. So just realize that it's the y hat means predicted. All right, so what we're going to do now is we're going to take a moment and we're going to type this into our y equals. All right, so we're going to type that equation in. So the negative 1 point, remember, hit your y equals, negative 1.9x plus the 102.2. And then when we graph it, it's going to put that line of best fit through it. So now the residual is from the dot to the line. So you can see we've got 1, 2, 3, 4, 5. It looks like we've got 6 dots above the line. Those are all positive. And then it looks like we got a couple of dots on the line. So I bet those are close to 0, but they're probably not exactly 0. And then we've got 1, 2, 3, 4, 5, roughly 5 that are below the line. Okay, so you should have about the same number above and below. And remember, those lines are going to cancel each other out. That's why it's called the line of, one of the reasons it's called the line of best fit. Now, what we're going to do, ladies and gentlemen, is we're going to figure out, we're going to use this formula right here. We're going to figure out, well, what is the residual for each one? All right, so what I'm going to do is I'm going to, and you want to pause this because I'm going to pause and get this filled in so you don't have to watch me do this through the whole thing. I'm going to go ahead and we're going to make 3 tables. Okay, so I'm going to go ahead and fill in this first table is the data I already have. Okay, that first table is this data. So I'm going to go ahead and I'm going to fill that in, and then I'm also going to fill in the temperature for my second table, which is the value that you are observing. Okay, so I'm gonna pause my recording, so I'll be back with you in a second, and I'm gonna have all that filled in. All right, be right back. Okay, ladies and gentlemen, just like magic, I am back and I've got that first table filled in. Again, that's the original data from up here. Okay, those are the observed data points. Those are the dots that I have on my graph. Now, what I want to do is I want to do what is predicted. Now, remember, on your calculator, the predicted is the line, the values that are on the line. So what I'm going to do, ladies and gentlemen, is I'm going to go to my table in my calculator, and I'm going to go to the 18 to see what that is. Okay, so to get to your table, remember, you go second y equals. Again, let me repeat that. To go to the table, you go second y equals. Jot these things down on your paper. All right, so what I'm going to do now is I'm going to go to 18. Okay, this can get kind of, since you got to scroll, you know, sometimes it takes, my calculator is slow. Hopefully yours is a little faster. So there's the 18, ladies and gentlemen. So the predicted value for 18 is 68. That is my predicted value. Now I'm going to go back to 10. So you might want to do these in order. Okay, let me start with 1. Okay, whoops, I didn't want to do that. Let me go back. So let me go back to my calculator, and I'm going to actually go smallest to largest. Then I don't have to scroll back and forth. So I'm going to go ahead and go back to my calculator and go back up to 1. Now I'm only going to do a few more of these with you because I don't want to take time showing you every single one. So I'm going to do a few more with you, and then I'm going to pause it and fill the rest in, and you can do the same while I'm doing that. All right. So here's the predicted value for 1. 1 degree, the predicted value is 100.3. Now to make life easy, folks, we're going to round it to the nearest whole number. Okay, let's just round it to the nearest whole number. So we're just going to say 100. So I'm going to go down here to 1 and put in 100. Okay, it looks like the next lowest value is 5 degrees. All right, so here's 5 degrees right here on my screen. So I'm going to round this to 93. So again, you can't sell part of a box of cereal anyway, right? So 93. So this is 93. That's my predicted value. Okay, it looks like the next one is 10 boxes of, or 10 degrees outside. So if it's 10 degrees outside, what is the predicted number of boxes of cereal? I'm going to say 83. So I'm going to put 83 in that spot. All right, hopefully you got the idea of what I'm doing here, ladies and gentlemen. I'll do one more with you. I'm going to go to 14 degrees outside. So I'm going to go to 14 degrees. Again, remember you have the power of rewind if you didn't get how I got here. Let's see if I round that appropriately. That would be 76 boxes of cereal. All right. All right, I'm going to, with the power of technology, I'm going to pause and I'm going to fill this in, and I will be back with you in a few seconds. All right. Now, if I can find my pause button, that would be great. All right, ladies and gentlemen, I have got that table filled in. So again, I found all of those by putting in my equation in my y equals, my least squares regression line, and then going second graph to the table and looking up. Those are all the values that are on that line. Okay, let me pull up the graph one more time. So again, those are the predicted values. Now what we're going to do is we're going to find the distance from the predicted value to the actual value. And we're going to use this right here. So it says take the observed value, the y value, and minus the predicted value. All right, so, well, the first one, the observed value is 74 boxes of cereal sold. And the predicted value is 68 boxes of cereal. Well, if I can do the math in my head, I believe that residual is 6. It's positive, so that means it's above the line. That first one is above the line. Okay, the next one is the observed is 70, and then minus the predicted, and if I can do my math in my head correctly, I believe that's negative 13. So that means that one is below the line. Okay, it is below the line. All right, I'll do 2 more with you, and then you can go ahead and pause and fill in the rest. Okay, so now again, I'm going to take the next observed value minus the predicted value. And let's see, 105 minus 93, I believe that is 12. Hopefully I'm not making any strange mistakes here. All right, and I'll do one more. So the observed is 60, and the predicted is 57. So that would be 3. All right, ladies and gentlemen, again, use the power of pause. Pause it. I'll be back with you in a second. I'm going to fill in the rest of that table. Okay, ladies and gentlemen, so there we go. Now, one thing I didn't point out earlier is that very last one, you notice we ended up with a negative amount of boxes of cereal sold. Now, remember, that is technically not possible, okay? The store is not going to give you the box of cereal and give you the money for it, okay? So, but, again, that's predicting beyond the data sometimes, and that's called extrapolation, all right? Now, we've got our residuals. Now, we rounded, so this would not work perfectly, but if we found the exact values, folks, and we would add these up, they would always add up to 0. Okay, because that line is supposed to be going through the center of the dots, and the positive residuals and the negative residuals are supposed to cancel each other out. Now, these probably do not add up to 0. Okay, I'm not going to take time to do it, but they probably don't because we rounded all of those answers. All right, now, I took you through all of that, and believe it or not, the calculator will actually find the residuals for you. Oh boy. All right, here are the steps. So you may want to pause this and get these written down. Okay, you want these in your notebook. So put the data in list 1 and list 2. We did that. We did the stat calculate number 4. Okay, nothing new there. Now, this is what's new. We're going to go to the top of list 3. We're going to push the second button, then the stat button. We're going to look for the word resid in the list, and then we're going to pick it. And then we're going to push enter, and the residuals will fill list 3. What? That is crazy. Okay? So pause this and get that written down. Okay? I'm going to go ahead and, in 2 seconds, I'm going to go ahead and go through it. Here we go. So on our calculator, actually I'll do this so that we can keep the steps right in front of us. All right, we already put the data in list 1 and list 2. See, there they are. We already did the stat calculate number 4, but I'll do it again. Okay, nothing like being safe. There they are. Once it did that, ladies and gentlemen, it found all the residuals. Whoa. Okay, now push, go to the top of list 3. So that means we got to go stat, edit, go over, now go up to list 3. All right, we're going to push the second button and the stat button. Okay, the second button and the stat button. And we're going to look for the word resid. Well, mine's in number 7. I'm just going to hit the number 7. You can scroll down if you want. I'm just going to hit the number 7. Ooh, we're almost there. Now, push enter. The residuals will fill list 3. Look at that, ladies and gentlemen. Wow. All right, let's look. Okay, let me pull this back. So here are our residuals that we found by hand, right? Now remember, we rounded. So let's take a look. Oh, look, that first one is rounded to 6. You bet. The next one is rounded to -13. Excellent. The next one we rounded to 12. Excellent. The next one we rounded to 3. Very good. The next one, -8, -4, -6. Look at that. The residuals, the calculator found them for us. All right, so I will expect you to be able to do these steps and find those answers. It'll be on the test. All right, ladies and gentlemen, let's keep going here. So the next problem is also familiar. We did this one. Does the age at which a child begins to talk predict a later score on a test of mental ability? A study of the development of young children recorded the age in months at which each of the 21 children spoke their first word and Giselle adaptive score. The result of an aptitude test is taken much later. The data appear in the table. All right, ladies and gentlemen, so what I'm going to do, again, you have the power of pause and rewind. Okay, here's the data, and then there's a couple at the bottom. I'm going to go ahead and type these in my calculator and get my graph all set up. Okay, I'm going to do the pause again. I'll be back with you in a second. All right, ladies and gentlemen, I am back. So we have the data typed in. Hopefully you got all the data typed in, and don't forget there's some on the bottom. All right, I've already got my graph up there. I've got it labeled, the explanatory variable, age at which the child talks, and the score on the test. Okay, again, we can do zoom 9 to see it on our calculator. All right, now describe the relationship between the age and the child's score. Okay, well, We did that earlier in the last lesson. The older the child is before they talk, the lower the score. Okay, again, the older the child is when they first talk, the lower the score. Okay, that usually means some sort of developmental issues. Now, find the least squares regression line. All right, so let's go ahead and do that. Remember, stat, calculate. Number 4. And voila, there it is. All right, so let's take a moment and write that down. I'll be right back with you in a second. All right, ladies and gentlemen, so again, stat, calculate number 4. And we can find that least squares regression line. Now, again, looking at the correlation here, negative 0.64. So, you know, this is not very strong, and it's not strong. It's moderately strong, okay? So don't forget about correlation. But I wrote the numbers down, and I rounded, okay? I rounded it to negative 1.13x plus 110. So I rounded that. And then on the calculator, I typed it in my y equals. And then I graphed it again, and I got the line going through the dots. So what we're going to do is we're going to look at the residuals for those, all right? So there's the line going through the dots. Now, what is an outlier? All right, we haven't talked about the outlier yet. Okay, we did it in when we did the box and whisker plots, but we haven't really talked about it here. An outlier is an observation that lies outside the overall pattern of the observed observations in the scatter plot. An observation can be an outlier in the x direction and in the y direction, or in both directions. Which points are outliers? Okay, well, ladies and gentlemen, there are 3 of them. Okay, this would be an outlier, this would be an outlier, and this would be an outlier. So those 3 are considered outliers. The first one, this one up here, is an outlier in the y direction. These 2 are outliers in the x direction. All right, now, what I'm going to do is I'm going to save a little time. So there's three children that are considered outliers. Okay, I'm going to label these for you so you don't actually have to look through the list. This is actually child number 19. This is child number 2, and this is child number 18. Okay, so here's child number 2. Okay, they were older, they were 26 months old, and they got a score of 71. Okay, then going down closer to the bottom, let's see if I can find those children. All right, so here's this is child number 18. Again, they were 42 months old before they spoke their first word, and they had a score of 57. And then the one underneath was only 17 months old, but had a high score of 121. All right, so those 3 are definitely outliers, okay? Now, it took a little bit of what you could do on the calculator. Here, let me show you this quick. If I hit the trace button, ladies and gentlemen, okay, notice I'm on the first child right there. And then if I go 2, okay, see it's blinking on child 2. And then I would have to keep counting if I keep hitting the right arrow key. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, there's child 18 way in the corner. Okay, I don't know if my video is covering it up. And then there's child number 19. All right. So again, I hit the trace button, and then I just used my right arrow key and counted until I got to those dots. All right. So child 2, 18, 19. Are outliers. Now, influential points. Those are ones that are in the x direction. Okay, well, there's 2 in the x direction, right? In the X direction, that would be child 2 and child 18. Okay, child 2 and child 18. Those are influential. They're outliers, but those are also influential points. 19 is not. Okay? Now, residuals. Ooh, what are the residuals for these children? All right, so we got to go through those steps. So again, I did the stat calculate number 4. I already did that. Boom. Okay, and then remember we go back to our list. So stat edit. We go to the top of list 3, so all the way to the top. We hit second stat. Look for the word resid. There it is, number 7. And then hit enter. So child number 2 has a residual of, I'm going to round it to negative 9 point, well, we'll round it to the nearest whole number, 10, negative 10. So child 2 has a residual of negative 10. All right, now let's do child 18. Child 18, that means, ladies and gentlemen, I'm going to have to scroll down to 18. If you look in the bottom left-hand corner of your calculator, you can tell when you get to 18. There it is. See, here's 18 in the bottom left-hand corner. So that child has a residual of, well, let's just say negative 6. Let's just round it, negative 6. And child number 19 has, so that's the one right underneath it. That one has a residual of, whoa, positive 30. Positive 30. So, ladies and gentlemen, child number 2 is well below average. It has a negative residual. It's underneath the line. Child 18 is below average. Again, it's got a negative residual. It's below the line. Child 19 is way above average because they have a positive residual, and that dot's above the line. All right. So I think that's enough with those two. This is example number 3. It's just we don't do the car number. So this would go in list 1. This would go in list 2. Okay, you can go ahead and try it, folks. I'm just gonna let you know that, and then you'd find the residuals. Okay, in fact, what I will do, I'm not going to show the graph. I'll go ahead and put these in my calculator, and then I'll write those residuals in that list, and then you check your answers. So go ahead and pause it now. I'll be back in a second. Just warning, when you type these in, you do not type them with commas. Okay, no commas when you type them in the calculator. Okay, so no commas. All right, I'll be right back. All right, ladies and gentlemen, so I've got the data typed in. Okay, I already did my residuals. Let me take you through that again. So here's what the graph looks like really quick. Whoops, that wasn't it. That's what the graph looks like. So as the number of miles driven increases, obviously the value of that car decreases, right? All right. And then I did the stat calculate number 4, and I found my least squares regression line. All right, so it looks like it's going to decrease by about 3 cents per mile, negative 0.03, round it, 3 cents per mile. And then 5,620.47 is what I used for my equation. All right, and then I found the residuals. Again, let me go through that one more time. So when we did the linear regression, it found the residuals. Go to the top of list number 3. Okay, do the second stat, find your resids, and hit enter, and voila, there are your residuals. So hopefully you found those, and and I rounded all of these. These are the residuals. Hopefully I typed them correctly. All right, and then the last question is, are there any outliers? If yes, which ones? No, there aren't. If you look at the scatter plot, ladies and gentlemen, okay, there are no outliers. There are no dots that are really, 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 really sticking out like we did on the last example. So the answer to this question is no, there are no outliers. All right, ladies and gentlemen, that was it. I kept it just under 30 minutes. Whew. All right, rewind, watch it again if you didn't get things. Good luck. See you soon.